So I want to make m the subject. Now, if you see m there, let me show you. If you see m there, see that, and you see another m there, chances are you might factorize, because you have to group them together and factorize. So let's do that. And again, number 1, 2, m is an exponent, means you are going to introduce logs. See, 2 of those things. So let's just do that. Introduce logs. So the first one is log, we just write it as is 1 plus m over 1 minus x to the power 1 over m is equal to log a. You just introduce, or ln, you're allowed to use ln. Then you drop this power, it goes there. So it's 1 over m. I think that log, and then it's 1 plus m over 1 minus x is equal to, back again, log a. Are you with me? And then from here, what you need to do, remember your aim is to separate m. We're trying to separate m there. At this stage, I'll say 1 over m, and then put this division here is same as saying log bracket 1 plus m minus log what? Log bracket 1 minus x. See, that is equal to log a. Alright, then let's close this. And then what do I do there? I'm forced to multiply by m here, multiply by m there, so that I can open that bracket. So it's log bracket 1 plus m minus log bracket 1 minus x, see, is equal to I multiplied by m, so it's m.
Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson.
Hello once again, our most developed student. My name is Confident and welcome to part 2 of this video. And in part 2, we are now looking not at question number 1, but part 2. This was question 1. Alright, so we did that, but part 2 means we are looking at question number 2 and trying to put it in full day. It's out of 20 marks also, and it's basic algebra mostly, but let's see where it takes us. So question number 2, and this is question 2. And again, guys, remember, be subscribed to the channel so that you can follow up what's happening. And then let's come back to this. If you want to benefit from these lessons, we also would like you to be a member, become a part of this family, you know. Okay, let's look at it. Say solve for x if, so what we have here, 3 to the exponent 2x minus 1 is equal to ln 8. How many marks was this thing? 5. Okay, algebra. I don't know why they made it that much from what I'm seeing here, but what we do, obviously, if ever what you want is an exponent, you see, whenever you want to make something the subject as an exponent, you can only do that by introducing logs or ln. So since already we have got ln, let's use ln here. So what I'm gonna do, you just write ln 3 to x minus 1 is equal to ln bracket ln 8. See, you introduce ln, but you know what happens to the exponent. When this is an exponent in logs or laws of ln, you drop that. So it will, but be careful now when you're dropping it. To say you put a bracket, it's 2x minus 1 in bracket ln 3, see that, is equal to what? Ln of ln 8. It's more like you're making x the subject of the formula there. You see what I'm talking about? You are making x the subject. So what you do, divide by ln 3. You don't want this, so you can divide. But what you do on the left, you do on the right. Divide by ln 3. You can use a calculator once here. Then from there, we have got 2x minus 1 I can actually take 1 to the other side if I don't want to waste time. So it would be equal to ln 8, alright, over ln 3. Negative 1 becomes plus 1. You see what I was talking about. Then from there again, divide by 2 on both sides. So I divide by 2, divide everything here by 2. See, I'm making x this subject, but at the same time it will give me 1's the value of x. So it will be equal to, you can then take my calculator here and apply it once. If you're gonna get confused, do it single. You can change ln 8 and then multiply by that. It's up to you, but I prefer like this. So what we have, let's start with this division line. The longer one, which is over 2, is the first one, and then I take the one on top, which is ln. See, it opens the bracket, and then I also say ln 8. So it opened the bracket, close and close. Just have to be careful. Over ln 3, then close it, then plus 1. So play forward and say plus 1, then go on and say over 2. That's that, equal to 0,8331, 0,8331, which is 0,833, yes, to 3 decimal places, 0,833. So if I can say 0,833, that is the value of x. You know, you can try to test this here on the original. Let me reduce this because I'm trying to fit everything here. You can try to test it here, you see. So you can put this answer here. Just want to show you how best you can use that. So we are going to test it and say with our original 3 to the exponent 2, and then our x is what? It's bracket 0,833. It won't be the actual answer there. I think that equal to is it 2,0785. That is my left hand side. See this answer? Let me say ln 8. See that I'm getting 2,7079. You see, it's not 0785. You see, so if you wanted the actual answer, like what you needed to do, if you want to get 2,07944, exactly like this, what you do is you don't have to round off. You take the original here and say fraction. Let me take it back. It was ln of ln 8, right? I'm taking it back to the original over ln 3, alright, and then it was what? Plus 1 divided by 2. This is the original. Then so you are going to say 3 to the exponent, say 2 answer. See, then it's minus 1. You can get that 0.079, I think. You get there 0.07944, the actual one. So it's up to you, but this is correct, you know. So that is that. When we're proving that thing, you tell me what you think. You raise. Next one, it says make m the subject of the formula if m is equal to a. 4 marks. So whenever you look at this question like this, let me write it down quickly. They want to make m the subject. So what I have here is 1 plus m over 1 minus x, and then you do this 1 over m is equal to a, right? They want me to make m the subject. Okay, so let's do this and work on it from here. So I want to make m the subject. Now if you see m there, let me show you. If you see m there, see that, and you see another m there, chances are you might factorize, because you have to group them together and factorize. So let's do that. And again, number 1, 2, m is an exponent, means you are going to introduce logs. See, 2 of those things. So let's just do that. Introduce logs. So the first one is log. We just write it as is 1 plus m over 1 minus x to the power 1 over m is equal to log a. you just introduce, or ln, you're allowed to use ln. Then you drop this power, it goes there. So it's 1 over m. I think that log, and then it's 1 plus m over 1 minus x is equal to, back again, log a. Are you with me? And then from here, what you need to do, remember your aim is to separate m. We're trying to separate m there. At this stage, I'll say 1 over m, and then put this division here is same as saying log bracket 1 plus m minus log what? Log bracket 1 minus x. See, that is equal to log a. Alright, then let's close this. And then what do I do there? I'm forced to multiply by m here, multiply by m there, so that I can open that bracket. So it's log bracket 1 plus m minus log bracket 1 minus x, see, is equal to, I multiplied by m, so it's m log a. Careful there, you need just to be sensitive there. And then what happens here, I need to bring these two guys together, the m that is inside there. Alright, now let's take negative there. I'm trying to see from here, this is log 1 plus m, right, is equal to m log a plus log 1 minus x. The m part, I'm still having m on two areas, but this is 1 plus, you see. It's a bit tricky there for me. I've got, if a moment I do that, it actually, so let me take this to the other side. It's log 1 plus m minus m log a is equal to log 1 minus x. From here again, it's a bit tricky here what to do with these two m. Okay, I'm here and I'm here. Let me see what it do. From here, I think somehow, okay, I'll say this has reached my end of thinking capacity here, because these two m, for you to separate these all together, it will cost my arm. I don't know how to do this here. I'm stuck here. It's either they made an error on this question, or okay, I'll say ding dong. Give me your thoughts, guys. I'm a bit stuck here. What do you think? How do you go about from here? If you're watching it, you might give me a suggested solution. Okay, suggested answer here, please. What do you think could have done? How do you separate m from here? So your input is important. Also, if you are aware, sometimes it's educators who also watch the channel, so give me an idea. If I get a solution from you or from anyone that is making sense, I will also repost this. Alright, let's move on to the next one. Without wasting time, is draw the graph of y is called cosec x between what values? Minus 108 is less than or equal to x is less than this 3 marks. Okay, cosec. Alright, let me see this. Y is equal to cosec. So let's do that. Y is equal to cosec x. And they told me when I'm drawing this graph is minus 180 to 108. They like that domain. It's what? Negative 180 is less than or equal to x less than or equal to 180. Alright, they like this domain. Look at this. If I'm to draw this graph here, let me bring in my values. Let's do this. Because it's minus 180, let me just draw this graph using the calculator. Let's draw it straight away. It's 3 marks. We can sketch this thing. I hope you guys can see this. So if I can do this, like I'll use this one. We can just draw like this. Okay, let me use something different. It will still be clear. Let me draw this graph like this. Let's see what shape, Alright, and then from here I think I will use this to say 30, and this is 60, 30, 60, 90, 120, 150 is 108. And then I do the same thing here, minus 60, minus 120, and minus 108. That's what they said. Alright, so now I'm going to plot this graph. Now if I'm plotting this graph, and then this is how to use your calculator will give you the answers here. So what you do is you just do here and say setup table is number 3. So f of x is equal to cosec, but you know what is cosec? It's 1 over sin alpha x. You see that? Close it. Equal to start. They say start from negative 180. Then you say equal to, and you are ending in 180. Equal to, and then step. I prefer to use 15 because 15 covers the special angle of 30 and 45. Now, there is the first one. Negative 180 is error. So we're going to use these points. I'm plotting with these points here. I'm looking at the simplified version. So you use this calculator. Minus 150 is negative 2. So minus 150. So I'll call this as, I think that's what you have. I'll call this as 1 and 2. Here is negative 1 and negative 2. So it says 150 is what? 150 somewhere here is negative 2. There is a point there. Alright, so I'll keep on bringing in these values. So we continue. You look at the simplified ones. Minus 90 is minus 1. So minus 90 is also in between here. Is minus 1. There is a point there. Okay. Let's move on to the next. That one won't give me. Just use the simple ones. Minus 30 is minus 2. Then minus 30 is there, is minus 2. There is a point there. Alright. We continue. Okay, 0 is error. So here, look at this. If it gave me error, what was the first one? It was 108. If it's an error, you must remember, like in hyperbola, it means there is an asymptote there. The graph won't cut there. It's an asymptote, okay? So even here, you saw there is another one here. 0 means it's an asymptote there. And then you continue. 30 is 2. And then let's look at that. 30 there. 30 is there. I get my 2 there. Alright. And then I think it will repeat those values. 90 is 1. Like previously, 90 is 1. And what else? 150 is 2. 90 is 150. 180 is an error. So 90 is 1. Not that 90, sorry. 90 is here. So 90 is 1. Alright. 150 is somewhere there. It is 2. And then now, something is important. Let's look at the errors where it was given. We said there is an asymptote on this line. I'll make it blue. This is more like an asymptote. Your graph cannot go outside these regions, and your graph cannot be also in here. These are asymptotes. So if you are plotting it, you must have a graph. I'll make it thicker. It's more like this is your graph. Remember, it mustn't show that it's cutting. It's a continuous graph. So in here, you can actually show it by arrow is going down, and then the other one also is similar. It's more like you have a graph like this. Alright, that's what you're having. So what do you say? You label the graph as y is equal to cosec x. This is the graph. Now, since I said I'm a sketch, let me take off my part here. It must be, remember, in your part you don't have a graph paper, so this was what you're supposed to come up with. Alright, then they say here, yeah, draw the graph. Now look at this. Yes, what are the asymptotes? There it is. What are the asymptotes of the function y is this? You saw the asymptotes, we just drew them, so your answer there will be, asymptotes are asymptotes, let's write them there. What were the asymptotes? Minus 180, or you can actually say x is equal to negative 180. The other one is what? X is equal to 0. These are the equations of the asymptotes. And then x is equal to 180 degrees. I think that's why they made it 3 marks, because that is that. It was coming for 3 marks each. Okay. Then here they say draw the graph of this. Okay. They want me still to draw a graph of this. This one is not complicated. Let me try to bring back. Alright, no. I don't want that. Let me try to bring back my graph here. And then they say I'll draw it in the same part. I'm not going to change. Draw the graph of negative x squared is this. But look at this. I'm just drawing a graph of, if you're giving me that, I'll say negative x squared is equal to y over 4 multiplied by 4 multiplied by 4. So I'm saying draw the graph of this is equal to negative 4x squared. Don't know why they say I must draw this graph at this level. This is N4, 3 marks, come on. This is a basic graph. This is just a basic graph, you know. I'm not going to do much here because this is a standard graph. Remember, the graph is negative. Let me just take this back here. Now this is a negative graph. Okay, now I'm forced to erase this. Let's come here and look at the graph I was supposed to draw. It's y is equal to minus 4x squared. Y is equal to negative 4x squared. You must remember, if you are drawing the graph of what? For example, y is equal to x squared versus y is equal to minus x squared. You must remember these graphs to say we are having a graph like this. Now x squared is this version, and then minus x squared is the other way around. No? So this is what you are having. So these are the graphs you see. That's why I'm saying it was a basic standard graph. So if I'm to draw then this particular graph and try to make sense out of it, remember it's a sketch. Then I'll do this and I'll do this and I'll have my arrow. You need to get your full marks still. Don't take it for granted. This is your y, this is your x. Now it must face down. So when x is 0, y is 0. You can also have a few points there just to show that you know. And then when x is 1, so you do this. When x is 1, so if you put a 1 there, what do you have? When x is positive 1, here, that is x is 1. Y is negative 4. So you see, you can have here maybe a negative 4, and then you have a 1 there. So you have a point here. Then you do the same thing when x is minus 1. So this was x is 1. So let me write it properly. When x is minus 1, again minus 1 doesn't change on the value of y. So you see that. And then when you sketch this graph, I don't need much. Remember, I know the shape of this graph. It's this. It's facing down. It's a graph. Okay. Like this. You can remove that point there and make it on the graph itself. It's there. So I'll make it there. So there is the graph. Same thing here. Okay, you see, there is the graph there. Y is equal to minus 4x squared. Alright. So there is the graph. And then what's the other question they want to bring here? They are saying, is the graph this a function or relation? Now, remember when you're testing for a function, there are two types of function, 1 to 1 function, and then a many to 1 function. Now many meaning 1 to 1 means x value, 1x value is to 1y value. Many to 1 means you have got x1 and x2 or different values, but they map to 1y value. Right, that is still a function. But if you have a many to 1, this is not a function. Why? Well, sorry, not that. I'm doing the other way around. So if you have a 1 to many, it's the other way around. 1 to many. Meaning what? You have got 1x value and then it's mapping to 2 or more y values, y1 and y2. Then we're saying this is not a function but a relation. So these are functions. So we ask ourselves, what we need is a vertical line test. A vertical line test is a line that you check. Are we having for maybe actually it's yes, a vertical line test. For every value of x, are we getting a single value of y? So look at this. If I say x is 1, negative 1, you see, one value of x, these are vertical line test. That's what you use to test vertical line. So you can say that I'm getting one value of x for every value of y. So this is a 1:1 function. So this is a function. So you can come back here and say yes, it is a function. Is the graph this a function or relationship? Number one, it's a function. It passes the vertical line test. It's a function. Then the next one is what? Is the graph blah 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 continuous or discontinuous? Now continuity and discontinuity, look, the way I was drawing it is whereby I was having a single movement. Continuity means it can continue. I'm starting from here. Okay, let me show you. I'm starting from here. I'm not lifting my hand. I go like that. You see, I'm not lifting my hand. So that graph is continuous. If a graph is discontinuous, it's like when graphs have got asymptotes, for example, whereby if let's say I draw here, now I want to draw to the other asymptote. The moment I lift my hand to draw to the other side, that's a discontinuous graph. Alright, so those are the kind of graphs, they call them discontinuous. So this graph is a continuous graph. Alright, so that's that part is continuous. Alright, so those are the things. Okay, not bad. It was 4 marks and there it's 20 marks. So guys, again, this is me coming to you to say, if you're benefiting from these lessons and you feel like they are giving you some exam preps, I will encourage you, if you are not subscribed, ensure that you are subscribed, because this channel has you in mind. You know, we need to know that there are students who are benefiting behind the scenes. Also, secondly, please leave us a comment. You know what your comments does? It keeps us engaged. You know, if you're leaving me a comment in there, I'm seeing, you know, it becomes more of a relationship. We are part of the family. You know, there is kind of an interaction I'm having. I might not respond same time, but trust me, those comments, I read all of them. And then third, you can ensure that you share it with your friends. You know, if you're benefiting, just send it to your friends. Tell them on your WhatsApp, check this channel, it might assist you. Those are the 3 things. Fourth, you can turn on the notification bell, but you know, there are many videos I'm posting these days, so it might annoy you, so that one is optional. But please subscribe, share with your friends, and leave me some comments. Now, why am I saying that? Because it motivates me to bring more of these. Your motivation is your subscription as well as your comment. Now, next one, we are going to question number 3. As I said, again, it's 20 marks. We are looking at integration mainly here, as well as sketching of that. If you are interested in this, check the next lesson, which is question number 3. We'll also, as I told you, go for 4 until the end. It ends in question 5. So if we have come to the end actually of this lesson, and I wish you all the best as you prepare for your final exam. The 24-minute lesson, remember, it is made with you in mind. Thank you.